In this video, I'm going to show you how to find the equation of a perpendicular line. There is one key concept that we're going to be referring back to all throughout our discussion of perpendicular lines, and here it is. If two lines are perpendicular, then the product of their slopes is -1. So that provides us with a really easy way to check whether two lines are perpendicular, and we'll also see how to use this idea to construct a perpendicular line. But for now, let's just get some intuition for what this means by checking whether each of these three lines is perpendicular to this given line here, y equals 2x plus 1. So which of these lines is perpendicular to that given line? How can we find that out? Well, we know that if two lines are perpendicular, then the product of their slopes is -1. So really all we have to do is take this slope of 2 and multiply it by whatever slopes we have in these lines and check that the product comes out to -1. If it does, then they're perpendicular, and if it doesn't, then they're not perpendicular. Okay, so slope here is 2, so let's write that down. So 2 times, what is the slope here? Slope here is -1/2. 2 times -1/2, what does that come out to? Well, 2 times 1/2 is 1, and then we've got a negative sign, so that comes out to -1. Great. So that means yes, this line is perpendicular to the given line here. So yeah, yes, perpendicular. Okay. Now how about this line here? Y equals 3x minus 2. So let's check it the same way. So let's take the slope here is 2, and then multiply it by the slope of the line y equals 3x minus 2, which is 3. So 2 times 3, what does that equal? That is 6. So no, that's not equal to -1. So nope. So no, the lines are not perpendicular. Okay, now our last example is a little bit tougher. So still we want to take that slope of 2, and multiply it by the slope of this line. But what is the slope of this line? We're going to have to do a little bit of work to figure that out. So why don't we take this equation and rearrange it into slope-intercept form. So we'll go ahead and subtract x from both sides, and we'll get that 2y is equal to 10 and then minus x, and then we'll divide both sides by 2. So over 2 and over 2, and we'll just get y is equal to 10 divided by 2, that's 5, and then minus 1/2 x. And just to rewrite that with the x as our first term here, we'll write y equals -1/2 x plus 5. So we can see our slope here is -1/2, and 2 times -1/2, well, 2 times 1/2 is 1, and then the negative gives us a negative, so -1, and yeah, so yes, this line is perpendicular. Awesome. So now one thing to point out here, look at these two perpendicular lines. Do you notice anything that they had in common? Well, both lines have slopes of -1/2, and -1/2 is just the negative reciprocal of this original slope 2. So is that just a coincidence, or does that hold in general? Well, let's take a look. Say we have two slopes which are perpendicular. Then we know their product of the slopes is -1. Let's just call this slope 1 will be m1, and then slope 2 will be m2. So if these slopes are perpendicular, then the product has to be -1. And if we rearrange that a bit, if we divide by m1, then we just get m2 equals -1 over m1. And so that tells us that one of the slopes has to be the negative reciprocal of the other. Great, so that makes sense that in general, whatever our slope of our given line is, we can just take the negative reciprocal, and that gives us a way to tell what lines are perpendicular to that given line. Let's put a box around this because it is a very, very important result. Arguably just as important as this first result here. The first result tells us a way to check whether two lines have perpendicular slopes, but the second result here actually tells us how to find the perpendicular slope if we have a particular line. This tells us how to find the slope of line which is perpendicular, and we're going to use that to construct perpendicular lines. Here's an example of finding the equation of a perpendicular line. We want to find the equation of the line that passes through this particular point, 2, 1, and is perpendicular to this given line y equals 2/3 x minus 3. So how can we do this? Well, we saw previously that the slopes of perpendicular lines are negative reciprocals, and we know that the slope of the given line here is 2/3. So we can use that to find what is the slope of the perpendicular line. And then we have a point, and once we have the slope and we have a point, we can just plug that into point slope form here. But first things first, let's go ahead and find that slope of the perpendicular line. We know the slope of the given line is just 2/3. So M1, the given line, that slope is 2/3. And now M2, the slope of our perpendicular line, is just going to be the negative reciprocal of that. So all we have to do is put a negative sign on and then flip the fraction. So negative 3/2. So that's going to be our slope here. So that's what we're going to stick in for here. This will be M2, the slope of the perpendicular line. Okay, so then we have a point, x1, y1. That's just this point here. That's a particular point on our perpendicular line, x1, y1, and we'll just plug all that information here for our point slope form. So we've got y minus y1. y1 is just 1, as we saw here. Y minus 1 is equal to m2. m2 is down here, negative 3/2, times the quantity x minus x1. There's x, then minus, and then x1 is just 2. So x minus 2. Okay, great. So now we've got our equation here, and let's just go ahead and simplify into slope-intercept form. So we've got y minus 1 on this side, and that has to be equal to negative 3/2 times the quantity x minus 2. Let's just go ahead and distribute this. So this is negative 3/2 x, and then negative times a negative makes a plus. Then 3/2 times 2 is just 3 because 2 cancels out in the denominator. Okay, and then get y alone, so add 1 to both sides, and what do we have? We have y is equal to negative 3/2 x plus 4. There we go. That is our line then. Here's another example, which is pretty similar to the previous one. We want to find the equation of the line that passes through the point 3, 4 and is perpendicular to the line y equals 2. So why don't we just proceed as we did before. Let's find the slope of this line, that'll be m1, and then we'll find m2, the slope of the perpendicular line, by just taking the negative reciprocal. So first of all, m1 is equal to the slope of this line. Well, this line has a slope of 0. This is like y equals 0x plus 2. So m1 is 0, and that means m2 is just the reciprocal of that, negative reciprocal of that, and that is just negative 1/0. But hold on a second. 1/0, that's not defined. So m2 is undefined? What is going on here? So there's an issue that arises when the slope is 0, because we can't take the negative reciprocal of 0. The reciprocal of 0, it's really not defined. So it's a lot easier to think about this problem visually. Let's go ahead and plot the line y equals 2. So that's just y equals 2, that's y-intercept of 2, and then has slope of 0, so it's just going to be horizontal like this. There we go. So there's our line y equals 2. And why don't we plot the point 3, 4 also? So 3, 4 is right here, 3 units over, and then 4 units up, right over here. So that's 3, 4. Okay, we want a line that goes through this point 3, 4 and is perpendicular to this line y equals 2. Well, visually, that's pretty easy to tell. That line is just going to be straight up and down because y equals 2 is just straight horizontal. So we want a straight vertical line that goes like this. And how do we write the equation of a straight vertical line? Well, the equation of a straight vertical line is always just like x equals a constant. Okay, so how do we find this constant? Let's just abbreviate it, x equals c. Well, how we find that is we plug in this point 3, 4 into the equation here. X equals c. Well, we plug this in and we get x is just 3, so 3 equals c. So that tells us what our constant is. So our equation of our line then is just x equals 3. There we go. That is the perpendicular line. And now we can make sense of the result that we got earlier with undefined slope. The result is a vertical line, and vertical lines have undefined slope. So yeah, it checks out pretty nicely. Alright, so now we know how to tell if a pair of lines is parallel or perpendicular, and in the future we'll also learn to use such properties to quickly solve problems which would otherwise take a while to compute, such as, say, testing whether 3 points are all on the same line.